Okay, so let's look at question number 4. A 0.2 kilogram stone is held 1.3 meter above the top edge of a water well. Okay, so it's saying that at this point, the height above, so this one is height, what should I write? HI, so 1.3 meter. Okay, and then it dropped into here lah, dia jatuh dalam water, and then the well has a depth of 5 meter. So the well has a depth of 5 meter, meaning the distance here is 5 meter. Why do I put negative? It's because this is our reference. So this is kind of like an x-axis. So that's why they put h equal to 0 here as a reference point. Okay, so this is our reference point. Anything goes up from this level is positive. However, if it goes below this line, this reference line here, it will be negative. Okay, so that's why I put negative 5 here. Okay, right, lepas tu, what is the gravitational potential energy? We have to find gravitational potential energy, which is equal to UG. Okay, ataupun U saja. Right, find before the stone is released as well as when it reached the bottom of the well. Lepas tu, we have to find the change in gravitational potential energy from release to reaching the bottom of the well. Okay, so this is quite simple. The formula is just basically U equal to mgh. The only trick here is the h punya value, whether you should put negative or positive. Okay, so that is the only trick untuk this question. I mean, when it involves the gravitational potential energy lah. Okay, right, so let's do Roman 1. Before the stone is released, so this is the before, this is the after. Okay, so before the stone is released, I'm just gonna call it initial, so mghi. Okay, so we have the mass, which is 0.2 kilogram times 9.81 times dengan the initial height, which is 1.3. Okay, so calculate that. You'll then get 2.55 joule as the gravitational potential energy before the stone is released. And then after it reaches, when it reaches the bottom well, it's just the same thing except the height is changed to the depth of the well lah. Okay, so 0.2, 9.81, HF is negative 5. Lepas tu kita akan dapat the gravitational potential energy to be equal to negative 9.81 joule. Okay, so when you get a negative gravitational potential energy, it means that the gravitational potential energy is decreasing. Okay, it is decreasing. Okay, what else? Oh, we have to find the change. So the change is just delta U, U final minus U initial. So the U final is equal to negative 9.81 minus dengan 2.55. So you'll then get delta U to be equal to negative 12.36 joule, meaning that the gravitational potential energy decreases. So as it reach the bottom of the well, the gravitational potential energy ni decreasing lah. Alright, so that is on question number 4.